Thank you and good afternoon. So I'm going to tell you about SmartMet server, how we are going to providing MetOcean data at Finnish Meteorological Institute. Little background. FMI opened its data in 2013, and basically everything FMI owns was opened then. Data is provided in freely and in machine-readable formats, and FMI Open Data Portal follows INSPIRE requirements, and actually the very same data portal works as Open Data Portal and INSPIRE Data Portal. Data scope is way beyond INSPIRE data specification scope. We have lots of instantaneous and weather and marine observations there. Our weather observations are provided in up to 1 minute time interval. And then there's sounding, mast, air quality, sound radiation, marine and lightning observations. There's also some radiation observations by Finnish Radiation and Nuclear Safety Authority and road weather observations. There's model data from 6 different weather and marine models, the weather radar images, and some climatological data as well. Data model comes from INSPIRE. The observations and point forecasts are provided as GML. There's 2 possible format available, time series observations and grid series observations. And gridded data is provided in appropriate binary format, mostly GRIP and NetCDF. In those cases, our WFS, which is our download service, members contains the metadata and a link to actual data. Our download service is Web Feature Service 2.0, simple profile. We are using stored queries, predefined datasets for user convenience to help users to find the data of their need. And we have 3 strategies for producing INSPIRE data products depending on the data source. For observations, we have a master database, Oracle SQL database in our case. And then SmartMet server keeps an in-memory database for latest observations. And the server provides logic for fetching the data from its local database or master database, depending on time coverage. The server then does on-the-fly formatting based on templates and provides INSPIRE-compliant XML responses. For point forecasts, process is pretty similar. We have weather model data or weather model data at file system, and SmartMet server memory maps the data and provides logic for interpolation of the data for requested area and time, or point and time. The server then does on-the-fly formatting based on templates and provides INSPIRE-compliant XML responses. For gridded data, getting data is a 2-phase process. Again, we have this data at file system, and SmartMet server provides relevant metadata in XML responses, but now WFS responses contains a link to the actual data, which is then provided by SmartMet server download plugin, which provides logic for interpolation and reprojection for data if needed. And some data format conventions can be done also. That's about background. Then about the server itself. SmartMet server is a data and product server for MetOcean data. It's produced and used at the Finnish Meteorological Institute, and it's originally used for our client service needs. It provides high capacity and high availability services, and data is always extracted and products are generated on demand. It's INSPIRE compliant and it's been operative since 2008. And for our open data and portal and INSPIRE services, it's used since 2013. It has several input sources, files, PostGIS database and SQL databases. And it has several output interfaces and output formats supported. Most important interfaces are WMS and WFS, but there are also some other interfaces providing some additional formats, and most importantly maybe JSON for web development and mobile applications mainly. For binary data, CRIP and NetCDF are supported. As I said, it's used for FMR Open Data and INSPIRE services, but it's also used as a backend for our mobile applications, our public web pages, our client services, and it's also integrated into a number of our clients' systems directly. The server is going to be published as an open source this year. It's going to be published in GitHub. We still have one or two practical issues we have to solve before we can actually push the code into GitHub, but I hope we can do it even next month, but I can promise we can do it this year. The source code is going to be MIT license. Architecture is the server contains front ends and back ends. Front ends works as a load balancers, and they have knowledge about back end services. Front end also provides very efficient product cache. Back ends contains actual, let's say, business logic and actual APIs. And it's notable that different backends may contain different services. The server code itself is a plugin-based architecture. There are engines providing shared access to the data and plugins providing APIs for clients. Most important interfaces, WMS 1.3.0. It generates first SVG images from data, and those SVG images are then rendered to raster formats if needed. This way we can support rich effects of SVG rendering model, and we can do styling with CSS, and we have direct browser support. Configuration is done with JSON, and it's notable that configuration variables can be overridden in the requests. This way we can support, for example, thresholds. We can, for example, draw images only where temperature is between -2 and 2 degrees, or we can mask content based on other parameter. We can, for example, draw precipitation areas only where wind gusts are over 8 meters per second. This is true use case we have. Okay, I have to speed up a little bit. Yeah. WFS. Okay, I talked about that already pretty much. It's INSPIRE compliant. There's basic profile support, but we mainly use stored queries, simple profile for user convenience. And then there's download plugin to provide binary data. Supported formats are CRIP and NetCDF, and it can slice and trim and subset data based on area, elevation, time parameters, and you can define a again in client requests if you want. Our setup contains 2 front-end servers and 5 back-end servers. And with that kind of setup, we can gain pretty good performance. In our production setup, we respond over 30 million requests every day. That means that our baseline is about 200 requests every second, even during night time, and our peaks are over 650 requests per second. Average response times varies pretty much depending on the requests, but it varies between 4 and 140 milliseconds. At the moment, our availability is over 99.95%. Most of our downtime is caused actually by our network, not the server itself. We have done some load testing with our production setups. Then we have got peaks over 4,300 requests per second with pretty good average response times. We have 2 queues for slow and fast queries, and it's notable that slow queries can be easily DOS attacked due to large data requests and heavy operations, but it doesn't affect on to fast query queues. Our roadmap for future, we are following WCS Inspire. This is my last slide. Following WCS Inspire support and profile, and we are implementing WCS when it's ready. We already have 1 version, but it's not in production use yet. We are going to support GRIP and NetCDF as input data natively. At the moment, we have to convert the files into internal data format first. It's going to be, it's quite soon, early next year development. And we want to clustering support over internet so that we can provide data from their original source without moving it around. Okay, that's all.
Thanks a lot, Roope. Maybe one question only, if there is anything burning, otherwise after the end of the session. Can we please use the microphone because the session is recorded?
My name is Julia from the European Weather Center, and my question is at the moment, what data volume do you serve at the moment in SmartMet?
We have very many kind of data. We are using mainly our own weather forecast and also easy weather global model, easy ensemble data, observations and so on.
But volume-wise, do you speak about terabytes, or do you know? Or
about 2 terabytes.
Okay, thank you.
Thank you very much, Roope. So our next speaker is Tomáš Kliment from the University of Zagreb, who will be speaking about a new way to collect Inspire data in the field through the use of the mobile web feature service. Tomáš, floor is yours.
Thank you very much, Mr. Chair. Good afternoon to everybody. As I was presenting, my name is Tomáš Kliment, and I prepared this contribution with my colleagues Kati Šlaj, Saša Vranič, Martin Tuchyňa, and Rastislav Holeček. We are from several institutions and companies, and we are kind of a GIS or Inspire enthusiasts. The title of the presentation is a new way to collect Inspire data in the field, and with a final or main output called mobileWFS mobile application. Very shortly the outline. Of course, before we start to conduct any project, we need some kind of a motivation, otherwise it will be very difficult to start anything. Then we have to base the motivation on a real use case. Then afterwards, I will try to describe the architectural sketch that we found that might be doable to implement, and then shortly describe the pilot implementation, and summary and future steps. The last point is a question that I would like to ask. It's kind of an opening to open a discussion among a group of experts, because we are all of us experts here. What was the main motivation or stimulus to even start to do something like that? Basically, we had done in the past many projects where we had to collect the data in the field, and we had really difficulties to find an appropriate, let's say, open source and not very expensive stuff regarding the hardware and software. So we decided to find some other solution. So we made some research where we found that there are already many free available applications that provide an interface where you could collect the geospatial data in the field. In addition, some of them already today provide some basic functionalities, how to talk with WFS interface. Some of them can read the data, some of them can even publish the data, but only to a project-specific WFS endpoint, which is, you cannot edit, so it's not very generic. And therefore, we understood from our research that there is not actually any, let's call it, generic mobile app which would allow the user to collect data exposed using WFS and then push them back using the transactional operations. The use case that we based our implementation was related to governmental services InSpire spatial data team, where basically the workflow would start from a GIS expert who is managing the geospatial data regarding the governmental services, storing the database, then exposing in InSpire spatial data theme for governmental services using WFS interface. Okay, so then we had the use case and we started the architecture, so design, so how we could do that. So we established the DBMS or the backend databases where we would store all the data, either the data existing or data newly to be collected by the mobile app. Then we expose them using standard open source software, which is very much known in our community, GeoServer, which allows to expose data using WFS 2.0 standard, and also allows to expose complex features using application schema plugin. And then we said, okay, that's fine, everything is cool, let's start to develop the mobile app which would do everything what we want. Well, but it didn't go so easy and so smoothly. Then we understood that basically, first of all, the XML data coming from the WFS, especially when we talk about complex features like InSpire themes, might be quite heavy stuff for the mobile app, of course, depending on the geometry, etc. So we would like to actually work with JSON representation in the mobile app, and we understood that this is not possible for complex feature using the GeoServer again. And then the second problem was that we also understood that we cannot do directly from the mobile app interface a transactional operations back towards featured complex types. So we had problems. So in order to resolve our problems, we changed the architectural sketch, or the way how we would implement, and we developed kind of a middleware which would somehow serve us in the way in the way between the GeoServer and our mobile application, mobile WFS, where basically what we do, user can just assign the WFS endpoint URL, then the app is sending get capabilities request, making a list of available feature types, then sending the request get records, and if there is a JSON representation available, fine, no problem. But for the complex types, as I mentioned in before, that we had problems, there doesn't exist a JSON representation of complex types. Then we send the endpoint and feature type to our middleware, which does basically the transformation from XML to JSON and sends it back to our mobile app, and then the mobile app is doing what it has to do. And on the other hand, also coming back, as I said, there's a problem to push back data using WFS on complex types. So we are using, again, our API, which receives from our app edited or updated or to be deleted simple types encoded using GeoJSON. and then basically sends, a set of WFST on simple types to the server. Okay, parallel implementation, the interface or the environment we used is Titanium Observator Studio, which is basically an integrated development environment based on Eclipse where you can write in JavaScript, HTML, and then basically generate the Java code, which is then pushed back to the Android device. And this is just to refer and acknowledge the development was based on a Proplan project, which was part of the MyGeo's second call. How does it look like? We try to make it as simple as possible. Maybe it's not true. But basically on the home screen, you get a very simple window where at the first initial start, you have we have some kind of user management which is very light. So we don't require any personal information from people. We would like from you only a nickname that you would somehow be a link to your observations. So there you can use either a demo for testing or you can create your nickname, and you will get hashtag some ID. Then you have information about the WFS endpoint, which is currently set in the app to be used. And then you have the observation summary, but you will see after, because this is the initial start. Then you have the main menu on the home window, where you can load the local data from the local app database if you had already done some observations before. Then you can change the WFS server endpoint. Then when you change the WFS server endpoint, you get the server data. So basically we are sending these get capabilities and providing a list of feature types available. Then you choose, and basically then the app is reading, well, if it's a simple type, reading JSON directly, but if it's a complex type, as I said, sending the request to our middleware and then parsing the JSON received from there, and displaying the data on the map, which is the second window of the app. What you can do, as I said, you can display in the current version only point and multi-point features, geometry. Then we have some definition of the user rights for individual observations that are displayed there. So you have like several colors depending if the observation was edited by you or is still anonymous or has someone else as the owner. And then how to collect the data in the field. So it's very simply basic stuff like, first of all, you can locate yourself. So using GNSS sensor, which is integrated in your mobile device. Then you can observe. Observe would mean that at the point where you are located, the app would create a new point. Or you can insert manually. So you can use also the manual inserting in the map. And the last function is a capture, which is basically, because one of the main goals of our app was also to have offline editing, because not always in the field we have internet connection, so it's good to work with offline data. So this capture basically does just stores the tiles of the background map, which is OpenStreetMap, in your local device for the extent, of course, not for on the global device. Then when you insert or observe the point, you can click on the point and you get the attribute window where you can basically collect the data, the attributes. This implementation is now a bit more specifically oriented, as I said, in the use case on governmental services. So we can take classical picture, then we provide a list of service type which is coming from the schema and INSPIRE registry to be defined, and some basic metadata that we found as important. Yes. Okay, I'm almost at the end, I think. Then, when you finish your work, so you come back home from the field, you will see on the home page back again the summary of the observations that you had done. So you can see that you collected, I don't know, 10 new observations, you updated 2, and you deleted 2 or something like that. And then on the top, you have basically an option to push then data back to the server. Which is, again, if we talk about complex features using this middleware, which transforms the JSON coming from the app to XMLs that are then used to push using WFST. Okay, summary and future. It's supposed to be, or the plan is to provide an open source mobile app which would be fully generic and compliant with WFST interface. Basically, currently what we provide is viewing existing data as points or multi-points, updating the data, only the attributes currently, and creating new by inserting or observing. What's for the future? What is missing today is the automatic generation of editing forms based on background schema of the feature types, which can be done using this guy feature type request and then somehow passing the data types definition, which can be also received in the JSON encoding. Yeah, and what's the user community? We see it as it might be useful. It might vary from academy, because I have some experiences from academy where we used this kind of approach. It can be, of course, governmental institutions that have to provide the data for initiative like or directive like Inspire, and basically the main goal is to provide an interface to collect the data based on standardized data models that, for instance, is Inspire models or national registries, and etc. Thank you very much.
Maybe 2 questions at max.
The app is not available yet because I had some problems last night. If that would be a question, but it will be soon.
So if not, I might take the opportunity. Did you plan something for access control in particular, assuming that the feature services, when they're in with a transactional profile enabled, probably should be restricted on the server side, so that the mobile applications should be handling this somehow? Did you consider when you were conceptualizing and implementing?
Well, not really. Not really.
Next step, maybe.
Yeah, well, that's what I had in my outlines, that there's still lots of steps. And the question I forgot to ask maybe for the community, would you see this kind of approach as something which is needed for Inspire implementation or not? This maybe if we have time.
So, anyone, please? Can you get the microphone?
So thank you very much for your presentation. I think it's very interesting, this. First of all, I would like to encourage you to promote this into the thematic platform, because I think it's a good initiative related with the utilities. Mm. And one question is, okay, this is just for single features, so to take points, or you are envisaging to create something to create more complex topology, okay, and polylines and polygons?
Well, I think my personal opinion is that when we, first of all, the main goal is to use really low-cost stuff like mobile smartphones, which have not really very precise GNSS sensors. So you might get something around 2 meters the accuracy of your location. And I don't know whether this would be kind of useful to observe more complex geospatial features like lines, multi-lines, or even polygons. If that would be something really needed. There I would see rather some more accurate geodetic methods. If there would be a use case, I don't know about it.
I have in my mind many use cases for this, and for different data set in which the geospatial component is still need to be checked, because not all the accuracy of the points. So, yeah, I think so. I think it's a good initiative.
I mean, the main objective here is to mainly verify the attribute values, and basically just to observe a point and say, this is the point I observed from, I took a picture, so, and from that point I can say that, the service type of this governmental service or school is higher education or...
Yeah, for example, for industrial facilities, I think it's very relevant.
For industrial facilities.
So I think both of you should talk more, maybe over a beer after the session. So thanks, Tomáš, thanks a lot. So now from the feature world, we will go and look at what's going on in the observation world. Our next speaker, Xalo Fernandez, from the Ministry of Agriculture, Food and Environment of Spain, will update us on the topic of SOS, implementation of an Inspire download service for real-time air quality data. The floor is all yours.
Thank you, Alex. Good afternoon, everybody. Yes, I'm going to show you the works we are undertaken at the Spanish Ministry of Environment to implement an Inspire download service with a SOS interface in order to distribute near real-time data coming from sensor networks, in this case from an air quality sensor network. Let's see the context of the project. There is the ministry, and we have some sensor networks from which we are collecting data or which we are managing, and we want to distribute the data coming from them through Inspire services. In the case of the air quality data, we already have view services for the real-time data and also for the filtered and processed non-real-time part of the information through WMS services. We have download predefined data sets of this non-real-time part of the information through an Atom interface, but we are lacking a download service for the real-time data, and this is the gap we want to fill. These are some figures of our air quality network. We are working with around 900 stations. We have 12 variables, 12 air pollutants that we are observing in an hourly basis, hourly updates, and we are building hourly, daily, and monthly time series. We have around 150,000 new records per day on the system, and we want to distribute this through Inspire compliant services. So we have some information where the time dimension is important. We have a high volume of records and a high rate of update. And so we have chosen the sensor observation specification to deliver this. Sensor observation specification is an OGC specification. The important thing here is that it's an observations-focused specification. You see here the concept of the observation is on the center of the data model. Data is encoded in these observations and measurements standard of encoding that is an ISO standard and that accomplish what is needed for Inspire data specifications dealing with sensor observations. But actually the specification is not Inspire compliant still, but there is an activity in the MIE working groups that has drafted an extension to the technical guidance on download services to include SOS on this technical guidance, and we were set in a workshop last Monday that it is on the way and that it will be an Inspire network service soon. And for this, we have chosen this 52 North SOS application. It's an open source development. It's the OGC's SOS 2.0 reference implementation. Has the Inspire extension because it has been developed in this MIE activity. And this was interesting for us. It includes an API REST interface that we wanted to publish to foster the development of further downstream applications with our data. And it has an embed-like web client that we are also using to show the data that we are publishing, because there are not many clients that consume SOS data nowadays. And well, this diagram is the data model of the databases of the applications. It was quite straightforward to implement this service, but we have faced some challenges. The most important was, the thing was that we have some constraints on data source load and maintenance on the connection with our database. We have a fixed original data model that we couldn't change because is the database that is collecting data from the sensors, and we couldn't change this data model. And this data model was very different. The data structure of this database was very different from the SOS data model. We didn't have any ATL tool available to do this, and well, another challenge was the need of unique and invariant feature IDs for the principal features for the main features of the data model. For the first one of these challenges, the data source maintenance and the loading of the database, we considered these 4 options. We have here the first, our original database. If you have an ATL tool, you can pack your data into transactional queries to the SOS service and just load fill your SOS database with this. This has the advantage that you are independent from the application and its changes. You don't mind if the application changes its data model because you're just exchanging information with standard service queries. But you have data duplication, you have 2 databases, and you need an ETL tool to do this. In the second one, you can build this data model transformation through SQL queries that are this, and transform your data model to the SOS data model and fill the service database. No extra software is needed, but you still duplicate data, and you are dependent on the software data model. If the application changes, your queries will change, and you will have to do the work again. We had this third option that is quite clean, and because the application has this Hibernate library that is one ORM library, object relational mapping, that translates from object-oriented applications to the relational database. And but we tried it, but as our data model transformation was very complex, the queries here, this goes with some XML templates that you have to customize. And if the transformation you are doing is very complex, the performance of the service will decrease because the work you rely all the work of this transformation on online on real time to the server, and so we think it's not a good solution in case of complex transformation. It's a very good solution if this transformation is simpler. But the advantages are that you have a direct connection to your original database. You don't have to change anything. The updating is automatically, because you update the data in your database, and the service has the updated information, but it has this disadvantage. And the fourth one, that is just like the second one, but just in building some views in your original database to show the service, the database with looking like that's what it wants to see. So here you don't have data duplication, but we had the doubts about performance. But actually we have chosen this solution, and it's working well with materialized views here in our database. But the conclusion is that the best solution, there's no one best solution, but the best solution should be decided in a case-by-case basis, depending on the initial constraints. For the second one, the issue with the feature IDs, the thing is that the main features of the model, the main feature IDs should be unique, invariants in the form of URIs. We have chosen this option of having URN as feature IDs with this template, where the ID, the final ID, is the unique numeric internal database identifier. And in the case of the observation features, in order to be invariant, in order to be unique, this ID is a function of the sensor, the variable, the sensor that is taking the observation, the variable you are observing, and the timestamp, the moment. And for the combination of these three, every observation has a unique identifier. And this could be easily convertible in an URL if in the next step we decide, for example, to publish our data, to open our data as linked data in the future and just open it in this way. And just to get to an end, I want to show you a video because we didn't get to have this service in production and on the internet, but we have it in our intranet, and we have recorded this video of our beta version last week. This is how this client looks alike. We have customized the appearance of the 52 North application, and here you have, the browser where you have all your SOS services. We only have this air quality one. In the right side, you have all the observables you can query. This is the geographical view where you can navigate the stations that are clustered. You can go to a station and see the time series you have there. We have these are the hourly time series, daily time series, the statistical ones for every observable. We can also find a place with this box. We are going to Barcelona, and we are going to select two stations, one in the north of the city, two hourly time series to see the real-time data. And when you select time series, you see this graphical representation. These are the records for the day, last Friday when we were recording, but you can make a wider time window. This is the whole week, the last week. And here you have the options to see some information of the time series, to download the information. Just checking here is what we are going to do now, and download records in CSV formats. We want to add XML and JSON formats to the download. And here we are going to, the video is just the end. And the other station, just to compare the records, and you can see there. And it's just for those of you that are not familiarized with the 52 North client interface, and you can toggle here from tabular view with actual values and the graphical one. And well, basically this is the functionality of the application. I will stop it now, and this is all. Thank you for your attention.
Thanks a lot. Xalo, questions? I know that in the audience there are at least two persons who have implemented SOS, so if you have any questions or comments on what you said, on what was said.
Hello, Sylvain Gray from Belgium. I'm really pleased to see some presentation outside O&M and SOS workshop of actual people developing stuff, because we've been trying to push that subject with Alex and others for years. So my question is, what led you into exposing those topics under Inspire? Is because you were concerned by the monitoring facility theme because of the air quality stuff? I mean, I'm really pleased to see such presentations. There are so few people speaking about observation within Inspire, so what led you in that process?
You mean why to make this Inspire compliant, or I didn't understand.
No, I'm saying that's really good to see that's done under the way we try to write that under Inspire, but basically who told you that there are documents in Inspire stating that? Because I see that, like, for France, my country, there are really few people aware that their observation should also be exposed under Inspire, and there are these specs to be followed. And some just do the other way around. So just the initial steps of the project.
Well, the thing was that we found this. I mean, we are building all types of Inspire compliant services to publish our data, and we found this gap on the real-time data in order to download it, and we thought about publishing it within WFS or other type of service, but we found better doing this way, and it's our first experience with SOS. We want to extend this to all our sensor networks. Water quality, we have weather, climate networks. Yeah.
Thank you very much. Very interesting indeed. So now we continue to stay on an atmospheric topic. Our next presenter, Rafal Vartanovic, representing the National Research Institute of Poland.
My name is Iurie Maxim. I'm a GIS manager in a private company in Romania called TeamNet. I was previously working in the Ministry of Environment as Chief of Protected Area Service and in the European Topic Center for Biological Diversity in Paris. My presentation would be about the WFS services in Inspire Geo Portal. I think most of the people in this room knows the Inspire Geo Portal, and we see here down a button which is called Resource Browser. If we go to this resource browser, we can see that we are able to choose between different type of services and if they are compliant or not. So here it is, how many resources are now registered in the browser. There are more than 300,000 registered browsers, in all of them. And in the left, we see how many of them are datasets, layers, download services, and so on. But if we are hitting the other button, which is saying how many are valid, only a little bit less than 4,000 are valid, which represent 1.3%. So from everything which we have in Inspire, only 1.3% are valid. And now let's look what is valid. We have an important number of datasets we see in the left. Most of them are datasets, so 2,000, almost 2,500 are datasets. Here are some pie charts with these resources, and we see most of them are datasets, and few of them are services, and even less of them are download service datasets. The same picture is for valid ones. Okay. Now, if we are looking at all these services, we see that for WFS exist only 741 WFSs, which are registered in the Inspire. These are not valid ones, so all of them are only 741 from all the 300,000 resources. So WFS has a very small number. But if we are looking at the valid ones, we see here all the valid ones download services. We see that only 2 WFS are valid, only 49 WMS are valid, and 18 Atom. And this is only from the last week, because last week we had only one WFS and only 2 atoms. And the number increased based to Cyprus, which launches new services last week. Otherwise, the numbers would be even smaller. If we are now making a comparison between all the resources and how many resources are valid, we see very small percentages. We are coming to percentages like 0.2%, 0.3%. So almost nothing which we have in our infrastructure is not valid. And this is validation, especially regarding metadata. Nobody is looking now at the data which we have inside, only about the metadata. If now we are making a comparison just to see how many resources we have in total, so I put there all the data sets and series which are discoverable in the Geo portal, we have almost 105,000 data resources, and from all of them which are valid, there are 69, which represent 0.05% from all the resources which we have in Inspire. So this is very unbelievable to my mind, and I will try to explain why we have this issue with these issues. So valid are 49 WMS, only 18 atoms, so even WMS are very few, 49. The other ones are not. 18 atoms, 2 WFS, and here I try to make a picture. So this black box, it's a picture of it's a picture which represents all the data sets which we have. There are almost 377 pixels by 377 pixels. And now if we are looking in the corner, in the upper left corner, in the upper right corner, we'll see how many of these data sets have some services there. Invalid, but they have some services. So only a limited number has some invalid view services, and even less have invalid download services. So all the other resources does not have any services at all. And if we are looking how many or few services are valid, then there are very few. It's like 7 per 7 pixels. This is everything which we have right now. Only these are passing the European Union validator. So what we made then? We said, okay, we have some problems with the metadata. We believe that people who did not understood that this entire infrastructure is not working with the metadata. The metadata is like looking for the books. If no some such cards exist in the library, you can't find the books. You have the books there, but you will not find them. If you are not providing all the information which is required in the metadata, as well, you will not find it. So you can publish all of your data in Inspire. Nobody will be able to find it. This is how it works. So here we have, as well, from this publicly available tool, we have all the errors which exist, and we see here in the corner that some of the errors are found with the coupled resources and with the stored queries. Here is a list with most of the issues why the services are not passing the validation. And issue number 1 is the coupled resource. So this is how the resources need to be coupled in between them. The services with the data sets and with the service get capabilities metadata document. Otherwise, if these links are not made, nobody can find your resources. Okay, why is this? Why these are not working? If we are going to the metadata editor, it's written very clear in that box that this metadata editor is creating metadata according to the Inspire implementing rules. But this is not true, unfortunately. Because even if we are looking exactly in this metadata editor, we think here that in the technical guidelines, it's a word there which said "and." And this "and" indicates that we need to have 2 fields there. It's written very clear that we need to have 2 fields. But unfortunately, in the metadata editor, we have only 1 field. So, therefore, even if we are completing that information in the metadata editor, it will not be valid. So it will work only if we'll edit manually in Notepad++ the metadata document and making it valid. Okay, this is for some people which knows what to do there and how to make this manually in order to add manually these tags for the metadata to pass the validation test. Now, issue number two. Issue number two, we saw, it's especially related to the stored queries. And people are not really doing this. I don't understand exactly why. We saw some example from Czech Republic, and we really appreciate because we looked at a lot at the Czech Republic WFS services when we've done as well our service, and they've done these stored queries as well. But most people are not fulfilling these requirements regarding the stored queries. Now, let's look at these few services which are valid. And we took all of these few services which are valid, and we looked, but are they valid or not? Are they passing other validators which exist now? Okay, they are passing the European validator, but are they okay? Are they passing other validators? So we took the Cyprus Atom services, and we inserted them in the OGC validator, and they failed. So even if they are passing the EC validator from the metadata point of view, they are failing the test of data. So less services which are passing the test. We took the two Austrian atoms, and they failed as well the test because they are shapefile and TIFF. They are not GML3 too. Okay, European Commission, the validator is not looking. He's downloading the data, he sees there a zip file, and say, okay, I downloaded the data. It is through Atom, it's okay, but it doesn't look inside. So they are passing the EC validator test, but they are not okay. Now we took the Cyprus WFS. We remember that there were two WFS. As well, we took, because there is no complex validation right now for administrative units, we took the OGC validator, and it fails again. Now we took our WFS, which we wanted somehow to pass all the tests, and we were able to validate it against as well EN plus validator. So we've done as well the validator of the, not only of the schema, but of all the values, thanks to the validator which was made by Epsilon Italia in a project. So now we can see as well this black cube. If you see the dot which is green there, is the only one service which is passing the test from all the data services which currently exist in European Union. Okay, some words about our data set. The data set is for protected sites, but it includes as well the administrative units, the biogeographical regions, and the nameplate in the same data set. Because I saw that many people understand that each data team, it's one data set, but this is not correct. According to the guidelines, a data set can be comprised of more than one data team. Okay. Now, just a short slide about our service. You can access it. You saw how you found it. It's very easy to find. You go there in the web browser, and you try to find the only one, the few ones which are passing the test from EC, and this is how you find. Of course, you can find it by a lot of keywords like protected areas, protected sites, whatever you want from Romania. You can find it by typing any name of any protected sites from Romania, and it will bring you the service. The service was done as well according to the version 3.0 schema, but we switched as well to the version 4.0 schema in order to be able to include in the dataset as well those feature types which are from Annex 3. Of course, the service can be accessible through KVP requests in the browser, and some examples of the KVP request. And this is maybe one of the most important KVP requests for which the datasets need to pass. If such a stored query for WFS service does not reply to such a query, then the EC Commission is not able to download the entire dataset. If it does not able to download, to see that the service is replying with this, it's saying, okay, I can't take the entire data set. If I can't take the entire data set, the data set is not compliant because this is required by the technical guidelines. So what we know about Inspire implementation, we know now that is possible. And I can tell you that in the last 2 years, I said, I don't think that is possible. I thought that is almost impossible to do it. Now we know it's difficult. It requires a mix of different technologies, and it needs to involve, at least in our case, a lot of people from all over the Europe. We were not able to do it by ourselves. And of course, I had a team with a strong commitment. For all of you, it will be better. It will be easier, because as we've done a small step, for you will be easier to follow because you will see some examples and you will understand why some services are passing the test and why some other services are not passing the test. So I want to thank to some people from which I worked, and as well to my team, which was able to do this service which I was able to present to you. Thank you.
Thanks a lot, Yuri, for the provocative presentation. Questions from the audience?
Okay, I have a simple question.
Yep.
Did you analyze, because the result is very poor, 1% or less, did you analyze how many percents was caused by bugs in Inspire validation? I'll give you one example, because our for example, metadata validation is 96% or something like that.
Yep.
Because there is namespace, obligatory namespace, but we are speaking about the data series. For example, for parcels, we have 13,000 files, and we do not want to give there some fake namespace. It's nonsense, and we won't play this role.
I'm not sure that I really understood your question. What we made and what I showed you in the presentation, it's what the European Commission tool it's showing to us. I am not able to validate all the services which exist and to analyze them. The validator from the Commission is doing for all of us. And this is what the validator is telling to us.
Can I just make a little point?
Yep.
The validator as it is today is not the official validator. That is being built as we speak through the MIWP5 work. Now, it's clear. I know that for the UK data, the records that fail the validation change regularly because Angelo Quaglia adapts and updates that validator on a regular basis.
That's completely right.
Okay, so how can a country who have their own schematron for checking whether the metadata is correct keep up to date with what Angelo is actually doing on a regular basis?
Okay, I want to tell you our story with Angelo, because we had as well a story with Angelo. We prepared this WFS service, and it didn't pass the validation. So we asked Angelo, why this service is not passing the validation? And he said, this service is not passing the validation because till now we didn't see any WFS service that can pass a validation, because we didn't see any WFS service that have stored queries in it, and we didn't see any WFS service that have coupled resources encoded correctly. And he's told me, as now we have a service, I can build the validator based on it. If we will not, if I will not have, if he was not able to have this services.
Apologies for interrupting, but we're a little bit outside of the time. The Inspire conference provides a good opportunity to meet. Our colleague Angelo is also here, so I suggest that you have a bilateral session with him. Well, in conclusion, following your presentation, I think that the fact that you concluded with the statement that it is possible is positive.
That's true.
I would like to see it also as a process. So if something wasn't possible last year, now we see that it is possible.
That's right.
The question is how to help each other, because we're all learning in this joint endeavor. So with this having been said, allow me to just share one personal feeling after having attended several Inspire conferences in a row. Some years ago, we were speaking a lot about pilots. Now we're speaking about real implementations, so we're really getting somewhere. Network services are operational now, and I take the opportunity to thank all the presenters for showing such outstanding results. Thanks a lot.